which is chemical bonding. And I'm your friend Kanishk Agrawal. And this chapter is very important. This forms the foundation of inorganic chemistry. This is a bit long chapter, but yes, if studied properly, and this is a very well structured chapter. So let's start from the very basics. Okay. So as the name of the chapter is chemical bonding. So first of all, we need to know that what is a bond. So forget chemistry for now. If I ask you that what is the meaning of bond, so like the first thing that must come to your mind is that bond is a kind of a relation, right? Suppose I say that I share a bond of love with my parents. So this means that I have some kind of relationship with my parents, right? Like from whom we will form the bond? From the person whom we like, right? So there should be a attraction to someone whom we have to form a bond and hence form a relationship. So therefore, similarly in chemistry, we define a chemical bond is a force of attraction. It's basically electrostatic attraction which binds two or more atoms together. Okay, so with the help of chemical bond, two or more atoms are bonded together. Now the very basic and very genuine question comes that, like, what's the need of a bond? Like, why should I form a bond? So why do we form friends, right? So basically because we like the company, because we like to be with them. Hence in chemistry, everything is about stability. Like not just chemistry, like no matter whether it's human or whether it's animals or whether it's the chemical units, right? Everyone in this universe wants to be stable. Nobody wants to be keep moving, right? Everybody wants to rest, correct? So similar way, a bond is formed due to attain stability and to lower down the energy. Means a chemical unit will be wanting to lower down its energy and should be and would be trying to increase its stability. So now the question arises that what are the ways a chemical bond can form and who are stable? Like I have talked about stability. So in chemistry, like there are so many elements and atoms like which are stable, right? So if I draw the basic skeleton of a periodic table, right? So like on the left hand side I have metals, right? So I'll just take a separate color for them. Okay, so there is hydrogen is a non-metal, right? So I have lithium, sodium, potassium and so on. Similarly beryllium, magnesium and so on. Like moving on, like here I would be having the transition metals, right? Scandium, titanium and so on, copper, zinc, correct? So basically here we again have the non-metals, right? If I see the second group, second period, I would be having here carbon, nitrogen, oxygen, fluorine. Okay, the last column is being taken up by the noble gases. So these noble gases, helium, neon, argon, krypton, xenon and radon, these are called as inert gases. Why they are inert? The meaning of inert is that they are chemically inert to the atmospheric changes, means they won't be combining to anything else. Hence I can say that they are perfectly stable and every other element in the periodic table wants to become like them. What do I mean by wants to become like them? Like you must have studied in your previous classes, and if not, so I'll just give you a brief overview. The electronic configurations, right? And you must have heard about octet rule, that whichever octet is complete, so that will be stable. And of course there's an exception for helium, because in the case of helium there's a duplet. So like helium is like 2 0 0 and so on. It is like 2 8, it will be 2 8 8 and so on, right? So because they have a valence shell complete, so hence they are stable. So suppose if I talk about carbon, okay, so carbon would want to have 4 bonds to become like neon. See, 4 hops, 1 2 3 4, Okay, similarly, fluorine would be just one electron away from helium. So see, like fluorine will be having the electronic configuration like 2,7, and if you have studied the atomic structure chapter, then it will be 1s2, 2s2, 2p5, right? So similarly, neon it is 2 comma 8, or you can just say 1s2, 2s2, 2p6, right? So as you can see that fluorine is just single electron short, hence the valency of fluorine would be 1. But like if I see lithium, so lithium is, as you can see, 7 you can say steps away. Like see, 1, then 2, 3, 4, 5, 6 and 7. So lithium needs to gain 7 electrons, but that's required tremendous amount of energy, right? Why is that? Because obviously lithium just has 3 protons to hold. So therefore, lithium will be trying to lose 1 electron and getting a stable configuration like helium. So helium is also a noble gas, right? So lithium would be happy with helium itself. So lithium would be wanting to lose 1 electron and become like lithium plus, which will having the electronic configuration like helium, right? So we have seen 2 major things by now. Someone wants to lose and someone wants to gain. So therefore, majorly speaking, bond can be formed by 2 ways. One is by sharing of electrons. Obviously, the loss and gain or the sharing of electrons only takes place. The proton is always fixed. And the second one is by transfer of electrons. What do you mean by transfer? Transfer means that loss and gain. Loss and gain of electrons. Hence, therefore, these are the 2 types in which bond is formed. Hence, we call them as sharing basis. We call them as covalent bond. And whenever there is transfer of electrons, we call it as ionic bond. And in some books, this ionic is also called as electrovalent bond because it deals with electrons, hence the name comes up. Okay, so I have a picture to explain you this. So see, these dots are electrons, right? So in the covalent bond, like I said, sharing is taking place. Okay, so whenever we share something, both of them are happy, right? And whenever transfer takes place, okay, so like eventually someone is happy, someone is sad, but they both also might be sad, okay, because they have taken something like that. Fine. So as you can see, in case of ionic bond, both the electrons are with single atom, right? So suppose I have a piece of chocolate, okay, so I'm not very good at drawing, so please excuse me for this. So you can have like 2 equal pieces because I wanted this chocolate to be distributed between 2 people like A and B. So when equal split is there, so this is a covalent bond. But suppose there is again one chocolate, right, and one is a very superior person and one is a little junior, okay, so obviously he would be wanting to have the all of it chocolate by itself. So hence this case is of ionic bonding. Fine. So we have covalent bond and ionic bond in which sharing is taking place, and in the case of ionic, transfer is taking place. So basically covalent bond is formed between an electronegative atom and electronegative because they both will be willing to gain electrons, hence they will sharing, right? So I can say between non-metal and non-metal. But when we talk about ionic bonding, it's between electronegative and electropositive because one wants to gain and one wants to lose. So guys, therefore these are the major 2 categories. There is one more form of bonding, that is dative bonding. That's an kind of extension of covalent only, in that the sharing is taking place but both of them are given by a single atom only. So that we will be discussing later on. So guys, this was the basic introduction of chemical bonding, and we will be continuing with the types of covalent bond in the next session. Thank you very much.